Hi, hello, how are you? Thank you for clicking this video and watching me. In this particular video, I will take some questions which are asked generally in entrance examinations of engineering, and I will try to explain these questions to you. And before each question, I am also giving the formulas regarding that. In this video, I am going to explain you the spectral lines of hydrogen atom. Firstly, here I want to tell you what is the hydrogen spectral of lines. It is found that when an electron jumps from one orbit to another, either it absorbs the energy or it emits the radiations. When an electron jumps from higher energy level to a lower energy level, it generally emits radiations in forms of spectral lines. And if we want to calculate the wavelength of those spectral lines, we have a formula which is derived by Mr. Balmer for the visible reasons, and with that formula we easily calculate the wavelength for different reasons. In the preceding questions I will tell you. One thing I also want to tell you, there are 5 types of spectral series we found. When an electron jumps from any shell to shell n is equals to 1, we found Lyman series. In the same way, when an electron jumps from higher shells to shell number 2, that is n is equals to 2, we observe the Balmer series. After that, for third one we have Paschen series, then we have bracket series, and then puffin, and goes on. In this way, when an electron moves from one orbit to another, it loses its energy, and these energy we observe in form of radiations. These are spectral lines of hydrogen atom. We study in case of hydrogen atom because it has a single atom. That's why it's easy to calculate there, and by that we compare with others. But in my preceding video, I just take some examples which are asked in engineering entrance examination, and they are formula based and very easy to grasp. Okay, now just move with me on the questions. Now there's another question in front of you. If H11, 12, 24, 38 all have one electron, these all 4 have one electrons, and there's a transition from n is equal to 2 to n is equal to 1. That means in all cases electron jumps from second orbit to first orbit. Then find a relationship in the wavelength, because these are all different elements, these are all different atoms, so they radiate different waves of different wavelengths, and we have to find the relationship between them. Now just keeping aside the constant, we have the relation 1 by n final square minus 1 n initial square. Clear? And we have the formula 1 by r z square. This is the Rydberg constant, but z square is important here because final and initial substance are same in each case. That means lambda has a relationship of inverse of z square. Clear? Now just do simply for, I'm just rubbing and write it clearly here. For example, in 1, 1 we have lambda 1, that means 1 by 1 square. Clear? For lambda 2 I have 1 by 1 square. Clear? Now lambda 3 we have 1 by atomic number is this 2 square, that means 1 by 4. In lambda 4 we have this is 3, it is 1 by 9. So we have a relationship lambda 1 is equal to lambda 2 is equals to 4 times lambda 3 is equal to 9 times lambda 4. And this way this question is solved. So just comparing we got easily the answer. So the next question is, now students see another question. Find ratio of maximum wavelength of Lyman series to maximum wavelength of Paschen series. We have to find the ratio of Lyman series and Paschen series. One thing I told you earlier that in maximum wavelength, we found maximum wavelength when there is transition from n to n minus 1. For example, 4 to 3, 2 to 1. Clear? Now comes to question. Lyman series, for Lyman series we have n is equal to 1, and for Paschen series we have n is equal to 3. So in case of Lyman, electron jumps from second to 1, and in Paschen electron jumps from 4 to 3. That means this is the final one and this is the initial one. Clear? Now comes to the question. We already have formula lambda is equal to 1 by Rz square 1 upon n1 square minus n2 square. Clear? So when we compare both these, when we take the ratios, this quantity gets cancelled in both the cases. We only left with this. So we have to find the ratio in between them. Clear? Now find the ratio. In case of Lyman series, we have the ratio 1 by 1 square minus 1 by 2 square. And here in Paschen we have 1 by 3 square minus 1 by 4 square. Clear? Or you can easily remember the lower digit must be there and higher digits must be there. Okay. Now we have 1 minus 1 by 4, 1 by 9 minus 1 by 16. That means we have, after solving, you can solve it. We got 3 by 4, and here we have 16 minus 9, 16 into 9. That means we have 3 by 4 into 7 into 16 into 9. Okay. Now solve it. We got 3 into 16 into 9, 4 into 7. That means 4 4 the 16. We have 100 by 7. This is the ratio. Now I am going to discuss another question. Just continue with me. Now, just read. If an atom is in the nth excited state, for example, there is an atom which has in the nth state, it comes to first excited state and it emits 10 different wavelengths. Then there is an emission of wavelengths and it emits 10 different wavelengths. And find the value of n. That means, for example, there is an atom and there is a atom in the orbit, and we don't know in which shell it is, and it comes to first excited state, comes to this orbit, and in this way when it comes to here, it emitted 10 different wavelengths. So we have to find in which orbit it is earlier. In these types of question we have a new formula. Just remember it. Number of emitted wavelength is equals to n into n minus 1 by 2. Just write it down. But now here in the question, first excited state. That means here this is the formula for ground state. This is the formula for ground state. But the electron in this question comes to first excited state. That means value of n here is n minus 1. So put the value of n here. Number of wavelengths we have 10, n minus 1. When we put here, it becomes n minus 2 by 2. Remember, this is the formula when the electron comes to ground state, n into n minus 1 by 2. But in the question it is given, it comes to first excited state. So in place of n, I have written n minus 1 and it becomes n minus 2. And just as we solved the quadratic, we solved it and ultimately we got the value of n. That means 10 to the 20. Here we have n square minus n minus 2n plus 2. That means n square minus 3n minus 18. Clear? Now 6 3 is 18 we have. It means plus 3n minus 6n minus 18, and we got n plus 3 minus 6 n plus 3. Now the value of n will never be negative, so the value of n is 6 in our question. So in this way we have the formula that when an electron jumps from one orbit to another, we can also calculate the number of emitted wavelengths by this formula. That means I again quote the formula for you. Just note it down properly and remember, this is the formula for ground state. Number of emitted wavelengths is equal to n into n minus 1 by 2. Now I am going to take another question. Just write the formula. Now there is another question in front of you. A hydrogen atom in its ground state is radiated by light of wavelength 970 angstrom. Then there is an atom which has the wavelength emission, it emits the wavelength 970 angstrom. If Hc by E, that means electron volt, is given this, and we have to find the energy of incident light. That the light which is incident on the atom, what is the energy of that light? We just remember, when we have to find the energy in electron volt, then we just simply divide it by wavelength. That means we have here 970, but it is in angstrom. That means 10 to the power minus 10 meter. We have 12370 into 10 to the power, that is not 970. It cancelled, and you just divide it and tell me what is the answer. It is approximately 12.7 electron volt. That it means if only wavelength is given, and if we have to find the energy, we just simply use the formula 12370 divided by lambda, and we get the answer in electron volt. This is the formula. You can learn it, and just in a second you will got the answer, the energy of incident light. Thank you. For more videos, just watch my profile. Bye bye.